Given that x and y are two normal random variables with mean mu and variance sigma squared, we're given that x plus y is equal to some constant value of s. What is the expected value of the random variable x? We know that the sum of two normal random variables is also a normal random variable. So let's take it as z is equal to x plus y. Now we are given that x plus y is equal to some value of s, which is the realized value, but let's find the distribution, the parameters of the distribution of x plus y. So the expected value of z would be equal to expected value of x plus y, which will be the sum of mu x and mu y. Similarly, the variance of z would be variance of x plus variance of y, since we are given that x plus y are independent. So we get z is a normal random variable with mean of mu x plus mu y and the variance of sigma x squared and sigma y squared. So we need to find what's the expected value of x given that x plus y, which is z, takes on some value equal to s. So we have to find this conditional expectation, and if you recall, this is the same conditional expectation which we find in OLS regression, wherein we estimate that the value of y hat is equal to expected value of y given x is equal to some value x, and y is distributed normally with mean 0 and variance sigma square. So this conditional expectation is a regression of z on x, just like here we had the regression of x on y. Now the bivariate conditional expectation of two normal random variables x1 and x2 is given by this equation here, where x1 and x2 are normal random variables with mean mu, variance sigma squared, and the correlation being rho. Now if you're familiar with the derivation in OLS regression, you would be familiar with this equation as well, but nonetheless I'll briefly go over the proof in the next few slides. Now I'm not going to cover this derivation in great detail, but just give you an idea of where this equation comes from. We have the expected value of x given y is equal to some value y. We can write this using the definition of expectation as x times f of x given y dx integral from minus infinity to infinity. Now the conditional distribution can be written as the joint distribution of x and y divided by the marginal distribution of y, and then we can plug in the values and solve to get the bivariate conditional expectation of x given y. Now there's more than one approach to solve this. You don't necessarily have to use integrals. You can just solve this using expectations. Now we know that the bivariate conditional expectation is given by this equation here, where rho is the correlation between x and z. Now as we have seen in the previous slides, mu z was equal to mu x plus mu y, and in the question we are given z is equal to s. The term rho times sigma x by sigma y, the correlation rho can be written as the covariance divided by the product of standard deviations. So we have the covariance between x and x plus y and the standard deviation of x times standard deviation of x plus y. The covariance between x and x plus y can be written as the covariance between x and x plus covariance of x and y. Now this term will be 0 because x and y are independent, and covariance between x and x is just the variance of x, which is sigma x squared. So putting in all these values, the above expression simplifies to sigma x squared divided by sigma x squared plus sigma y squared. So finally we plug in all the values to get the final answer. We had to find the expected value of x given x plus y is equal to s, which is equal to mu x plus sigma x squared divided by sigma x squared plus sigma y squared times s minus mu x plus mu y, which is the final answer to the question. Drop in the comments below how would you approach this question. Also, if you would like me to cover any other topic, let me know. Thanks for watching.